All right, good day everyone. This is Jason Straight with the Pass Cloud Virtual Group. Our presentation today is Big Data Architectures and the Data Lake. Our presenter is James Serra. Before I hand things over to James, I'm just going to go through a couple announcements here, and let's just get started. So over the next few weeks, we of course have a number of sessions that will be coming up. I think there's still 16 or 18 that are still in the pipeline. So I encourage you to take a look at what's out there, because you may find that something that you're trying to dig into as far as Azure and the cloud goes, that there is a presentation coming up that can cover what you're looking for. And of course, if you ever do miss a session, I do try to get them up to the Pass TV site within a week or so of when the sessions come up. Just due to how many that we have, and sometimes we'll queue them up a little bit before they go. If you are interested in presenting, the calendar doesn't end at the time that we have the last presenter there, so there is always room for more presenters. So if you are interested in presenting, you can email me at cloud@pass.org, or alternatively, go out to the cloud.pass.org website and click on the link there that will open up a Google form, and you can fill in all your details, and then I'll work with you to get scheduled to present. Over the last couple of weeks, Pass did make a few announcements coming up with Pass Summit 2019. So as of now, all of the community call for speakers sessions have been announced. So if you're trying to figure out what's going to be at Pass and trying to find out if it's worthwhile for you to go there, because you're looking to learn something very specific, about 200 sessions were just released. So you can go out there and take a look at the Pass Summit 2019 website. You can go out to the conference sessions and see what's all available. Something new for this year is the Pass Summit All Access. So it is a contest that Pass is holding now through August 23rd, where you can win a chance to receive a complimentary 3-day registration and exclusive access to some activities at the Pass Summit. So if you haven't registered yet, I would highly recommend going out there and taking a look at that, because that might be a way to get easy access to the Pass Summit. If you are still looking to register and you haven't yet, you can get a discount through our virtual group. This discount is there on the screen. Write it down now, or go out to any of our sessions from the past few months, and you can get that discount code there, or send any of our newsletters. This virtual group is part of a number of virtual groups that are out there and available through Pass. Some of them focus on different aspects of the data platform, like data architecture and data science. Others focus specifically on language, like Global Chinese and Global Hebrew. They provide a lot of opportunities for folks to learn more about data platforms and get, just build up your skill set. So with that, I'm going to just let people know that at the end of the session, we'll be having a time for questions. If you do have any questions, please type them in throughout into the question panel, and then I'll hold them until the end so that we can get them all answered at one time. All right, and with that, our presentation today is Big Data Architectures and the Data Lake, and our presenter is James Serra. So James, I'm going to make you the presenter.
Awesome. Thanks, Jason.
Right screen here. There we go. There you go.
Just give me a thumbs up. You can see my presentation.
Yep, I can see it. So I'm going to mute myself because we got construction here going on.
Okay, awesome. So welcome, everybody. My name is James Serra. I'm a big data evangelist at Microsoft. I work in a New York City Microsoft Technology Center, or MTC, as a data and AI architect. And I pretty much spend day in, day out engaged in customer conversations, whiteboarding sessions, architect design type of sessions on modern data warehousing as one of the focal points. And these full-day engagements are often with architects from particular customers who are migrating or building a new solution in the cloud, and they want to understand not just our products, but the use case of those products and some concepts. And the big one is the data lake. And as you'll see, that it's pretty much the focus of any project that's built in the cloud as one piece of a large puzzle. And I'll go through some architectures of what they look like, and happy to take questions at the end. And there's my email if you have follow-up questions that you want to send me an email afterwards. A little bit about me. I've been in Microsoft 5 years. I've been in the industry forever and have always focused on the Microsoft products. I was a former MVP, and I have a blog site at jamesserra.com, and a lot of things I talk about during this presentation will be covered in the blog if you want to check that out. So here's the agenda. We'll talk about some various architectures I'm seeing, why you want to use data lakes, the difference between top-down and bottom-up architecture. We'll go into a little bit more exactly what is a data lake and how does Hadoop fit into place in that context, the modern data warehouse, federated querying, and then some example solutions in the cloud. So if we look at the big data architectures, when somebody is going to build a solution in the cloud, many times they already have something on-prem and they're looking to migrate it. But you can't just say, well, go and build this new solution in the cloud and we'll flip a switch and everything gets converted over. Usually it's a migration piece by piece, and it's a hybrid solution. And many times this first architecture comes into play where a company has an enterprise data warehouse, but it's run into some issues. It doesn't have a space anymore on the SAN, or running out of performance, or it's got some maintenance window, and they just can't handle any more data, especially when it comes to non-relational data. Maybe it's some device information from IoT, maybe it's social media data, maybe it's competitor data. And so as a way to help answer better questions, get better answers from the data and incorporate more data, what they do is they create what's, I like to call a data hub, not so much a data lake, where it's supplementing what they have on-prem. And in the cloud, they build this data hub, usually in Hadoop. I do see a few cases of NoSQL, but I would say 95% of the time it's done in some Hadoop solution. And this is where they will take this data that they can't handle on-prem, devices, web logs, social media data, sensor data, and put it into this data hub in the cloud. And now they can supplement their on-prem with this data, and they come out and generate reporting, querying off of both sets of data, the on-prem and in the cloud one. So some of the cons of this is you're not really offloading an enterprise data work. It's still plugging along. It could be under stress. You're not helping that situation out. You may not be able to use existing tools because now they have to handle data in two different sets. So it's also very difficult to combine data from both. And so I'll see companies will say, look, we're just going to, for now, pull in social media data, Twitter data. We're going to analyze it, and we're not going to supplement it with on-prem, and we're just going to have it as a separate thing for now until we move everything into the cloud. So this is many times the first step. But to get some value out of this data right away, they come up with a data hub. The other is creating again, I'll call it a data hub in the cloud and having your enterprise data warehouse migrated. However, this data hub pulls in this new data into this along with the source system data so that they've migrated everything and they're building a new solution. But many times it's from migration. And this is used, think of it as a staging area in your enterprise data warehouse is now pulled out and put into this data hub. And you can process data in there before it moves to enterprise data warehouse. So this is getting closer to the ideal solution. But the cons of this is this data hub is a temporary area. It's just a staging area. Things are deleted afterwards. Nobody has access to this for reporting purposes. Rather, it just gets cleaned and the data gets moved into the enterprise data warehouse, which could be a big advantage because you're offloading a lot of that cleaning processing into this data hub. And so it does serve a great purpose, but this is not the ideal state. You want to go one step further. And that's this all-in-one, where this data hub, well, let me preference that. This is I kept this slide in, even though I don't see it much anymore, but there was some people who thought, well, I'm going to use a data lake for everything, and I'm going to have this Hadoop solution, and I'll put it out there, and I'll just start loading data in there, and I don't need a relational database, and that's always a big mistake. You always want to have a relational database component along with your data lake in there. Don't go in there and say, I'm just going to put everything in a data lake and bypass the relational database. And I've seen companies do it. I've seen a lot of horror stories where it failed miserably. I'm not going to beat this into the ground, but there's a link that I have below here where I talk about, is a traditional data warehouse dead, meaning is the relational database? And I make hopefully a strong case that you should always keep your relational database in here. But I kept this slide in there, even though it's pretty rare that I see people trying this anymore. Ideally, what you want to get is this modern data warehouse where the data lake has become sort of the center of the universe. All data, source systems, on-prem or in the cloud, are first going to go through the data lake. So it's not only a staging area like the second architecture, but also an area that can be opened up for querying. So I can put the data in the data lake, and this is giving you the best of both worlds. By having a data lake, which is just a glorified file folder, so it's schema on read, and the benefit of that is I can put files in there in these folders, and people can have access to it right away. However, you have to pay the piper somewhere, and schema on read means when I pull the data out, I have to understand it well enough. I have to give it schema, and I have to be that power user, the data scientist that knows the data, knows how to join it, knows how to clean it. But for those that want that, they have it. They do not have to wait until the data goes through a data lake and then into the relational database, which could take IT some time to do. If they have the skill set, they can go and use that data right away. Others are going to wait till it goes to enterprise data warehouse because they want it in a relational format. They may want it in a tabular model, a cube. So it's really easy to do self-service BI. You're just clicking and dragging fields on something like a Power BI reporting tool on there. But you have multiple copies of the data, but during each copy, you are updating and configuring the data so it makes it easier for certain users to be able to access it that way. And you also get a lot of other benefits from this, which I'll hit on in a few slides coming up in here. But this is the ideal goal, and this is where I tell each company you eventually want to be when you're building out that solution or migrating a solution. So why do we want to use the data lake? Well, first we look at the traditional process that we've had for many years. And I pull this data. I have an ETL, probably SSIS. I land it schema on write. I have to configure the relational database and allow the ETL to populate these database tables, fields that I've created in there. And it could take a long time to get there. And then any data that's not needed is deleted. So I don't want to keep data around. And I was a DBA for many years. I know the pains of having too much data in a database that you don't need or not going to use. You want to get rid of it in there. And that could be a problem if later you decide you actually did need that data, and that's where the data lake comes into play. But this is a traditional process, but it had some issues with it. And those issues come into play, especially when you're looking at to collect any data. When people ask me what is big data, I usually say it's all data. I can collect data no matter what the size, the speed, or the type of data in there. You look at all those various V's that people will talk about. And if I want to handle structured or unstructured, semi-structured streaming data on there, this is where we need the modern data warehouse. This is where we need a solution that can handle all this type of data. And in the end, you get the right information to the right people at the right time in the right format. And those three V's I talked about, as we're seeing, and this is what I see constantly in my daily engagement with customers, is they're trying to capture more and more data. Social media data now has become big. I can use Twitter, and I can use an analytics on that, and I can see what people think of my company or my product in there by grading each of the tweets. I can pull in weather data, competitor data, IoT data. I can stream it in there. I can generate reports that are live in there. I want to be able to handle terabytes or petabytes type of data in there. I want to handle data no matter what the field is, what the type is behind the scenes. It could be JSON, XML, video files, all of that I want to be able to incorporate and get value out of that data and make better business decisions. So because this is expanding so much, you need a solution that's going to handle this type of data. So the new thinking that we have, and customers are agreeing with this, is that all data has value in there. So I want to take this data and I want to hoard it all, and maybe I'll use it in the future, maybe I won't, but give me a solution where I can capture this data and then make sense of it now or in the future. I want to not have to do a lot of work to land the data, and that's where the schema on read comes into place. I don't have to define anything up front. And then users can pull in that data and use it as they see fit. And then I can iterate through that data as I analyze it. I get some results. I can go in and iterate back and collect more data, clean it, join it differently. And this becomes a great cycle of getting more value out of your data. And the difference to understand the way you may traditionally have captured the data and the way that you're going to do it in this modern data warehouse is top-down versus bottom-up. So think of top-down is, I know the questions to ask. I have to do all this upfront work to get, before I get the data. So in essence, I'm modeling it first, and that's what I mean top-down. You create the model first, and you populate it with all the data in there. And generally, this is traditional historical reports. I want to know my year of sales. I have all these questions. I just want to generate reports, operational reports, maybe some dashboards that show me the answers to those common questions I have. Where bottom up is you get the data first, then you model, and that's why they call it bottoms up, is you're not quite sure the questions to ask. You have this data, you want to investigate it, you want to play with it, and eventually you'll have questions, but I need to just query this data now to see what I got and what I can do with it. If I have a bottoms approach, I don't have to do any work up front. I can land the data in the data lake, and then I can do some work to pull it out, but it could be pretty easy if I know how to, if I have that skill set in there, and I can start querying and requerying until I get some great results, and then maybe I make that part of the relational database. But for now, just give me an area to play with. And if we look at the top down, it's historical, and we'll look at what happened, why did it happen, whereas the bottoms up, when we get into putting data in a data lake, we're often getting into the prescriptive or the predictive analytics, trying to guess what's going to happen in the future and how can we make that happen in there. So this is where we start getting into AI and machine learning and products like that. Those work very well when you have data in a data lake, and the data scientists can play with that data and do those predictive modeling on that. The data warehouse that we've come to know and love over the years uses that top-down approach in there. So you get the business requirements, you talk to the end user, you go and build out the data warehouse, and then you populate it. And that traditionally can take quite a long time to see value. So your return on investment could come, but it just, and nowadays it could be too impatient. We need to see some results now. And the traditional data warehouse has to morph into a modern data warehouse so you can get value out of the data quickly. And that's what you do with the data lake, is I can take all this data, I put it in the data lake, and I can start generating results on it right away. Not where I would have all my users do it this way, those power users and data scientists again, but they can get value out of the data. If nothing more, that they can see if this data even has value, and then they can move it to a modern data warehouse, as opposed to the thing I hated at being a DBA is when somebody says, oh, we have this data, I think it would be very valuable. So I'd write out some SSIS, I'd build this model into the relational database and SQL Server. I'd spend all this time, I put the data in the tables and then generate reports for the end users, and they come back and say, oh, well, the data is meaningless to us. It doesn't help us. I'm sorry. Well, I just wasted weeks building this out, and now you're going to tell me it's not useful. So we can turn it around and say, look, I put the data out there, go and tell me if it's useful or not. And if it's useful, you can get value out of it right away, and then I can make it into a longer-term process. So that's where having both of them together is so much better in there. I get the best of both worlds. I can look at prescriptive of what happened, and I can also do the predictive and use the machine learning tools to find out what will happen. So let's jump a little bit into a data lake. And this is a slide that started out with a few reasons, and over the weeks and months, I keep adding more and more reasons why a data lake is helpful as I see customers incorporate a data lake into their solutions, and they tell me about additional benefits they've had. And I won't go over all these, and the deck will be available afterwards for you to have as a takeaway. And so some of these that are high importance on there is if you look at some of the products to build a data lake, and Microsoft has a few options. The newest one is Azure Data Lake Storage Gen 2. It's unlimited scale. There is no ceiling. You can put data in there as long as you want, as much data as you want, and you're never going to run out of capacity. It's Azure. It's huge. It also can be very inexpensive. I mean, that's a relative term, but we have different layers with object tiering where you can have high performance, you can have hot, you can cold, you can have archive. We just cut the archive price in half. So you can build a solution where you can save a lot of money by moving it around to these object tiers. You add a little more complexity, but you get the benefit of saving a lot of money on there. So you have this single voice version of truth by having all the data in one spot. You can hoard the data. You can put data in no matter what type of it is in there. You don't have to model it. I love it because it frees up the expensive resources on an enterprise data warehouse. A lot of companies, they're trying to, during night, have a maintenance window, and they're running these queries, or they're running the data loading, but at the same time, if they want to have end users query, they usually can't because the data loading is overwhelming the resources, and you just can't have reports running while you're loading. And that goes away because you can do all that loading and transforming inside the data lake and avoid the contention with users in the relational database in there. It allows to have, I like to say, exploration to see if that data has value while it's in there and not have to go through all that work, as I mentioned before. It's great, especially if you have streaming data, which is extremely difficult to get into a relational database, but it's very easy to land it into a data lake in there. You can also use this data lake for archiving, so older data can sit in the data lake and the newer data can sit in the data warehouse, but the data warehouse can still get access to that data. And it will take longer to get it, but you're offloading a lot of that older data. So there's a trade-off there, but you can have better performance and not run out of space in your relational database by having the older data in the data lake in there. You can also use it for backup. You'll have in the products in the cloud, you'll have built-in high availability disaster recovery. That's a separate subject in there, but the durability on Azure Data Lake Storage Gen 2 starts at 11 nines in there, so you don't ever have to worry about losing the data, which is a big difference than building something on-prem. I also like it because you can keep the raw data in there. So when I was a DBA and I put that data, raw data in the staging area in the relational database, I would process that and then I would delete the raw data. Maybe I'd keep a day or two around in there. But what happens if I found a bug and I have to go back from data from a week ago or longer in there? I now have to go back to the source and pull that data in again. With the data lake, you just keep your raw data as long as you want. It's always there. It can always be used to rerun things. And so that's a high level of what's on some of this slide. And then let's look at the traditional procedures of I take all these data sources, I use ETL, I put it into a data warehouse, and then I run some BI reporting off of that, and I monitored all that. And that works pretty good up until you start having more data that you want to incorporate. So this is what I see happens with companies. They get additional data, sometimes non-relational data, maybe it's social media data, and they're trying to incorporate this on their on-prem system. Well, everything starts increasing in time in there, and you just don't have time for monitoring now because you can barely keep up with putting things in there with this added stress in there. Then you start getting stale reporting because maybe you can't update the reports as much because you're having capacity and performance issues in there. And then users start going off doing their own thing and it becomes a big mess. With the data lake, you think of it also as ELT, not ETL, where I'm taking all this data, I'm loading it first as is in its raw format into the data lake. Then I transform that data. I maybe have multiple data lake layers, which we'll talk about in a minute, where I put the clean data. And then I take that data and I transform it and then put it into a relational database and then start doing my reporting off of that. And on the top left here, you see I took that data in the data lake and I have it into the data warehouse so I can do BI and reporting off either one. And this allows me to handle data, again, no matter what the size, the speed, or the type. I often get asked, do I have to have every data go to the data lake? And I always say no. There are cases where you may want to pass the data lake. Every situation is different with data, so there's no one tried and true method of collecting all that data in there. I'll see customers who have hundreds, if not thousands, of SSIS packages, and I want to go tell them to rewrite every one. Maybe for at least a short term, you have those SSIS packages right to the data warehouse, and just maybe some of them that are slower are going to use the data lake, and for those data scientists that also want the data in the data lake. So on migration, many times it starts out with a large majority of the data going right to the data warehouse, but then they start converting all the packages to put things for everything from the data lake. Otherwise, you'll lose out on all those benefits I mentioned in the previous slide in there. And this, at a high level, think of it, it changes the way you think of data analysis, where instead of structuring the data, ingesting it and analyzing, I can now ingest it, analyze it, and then structure it. So think of it in those terms when you go to the data lake. The thing that always comes up with the data lake, and where I see a lot of problems with companies not understanding this well enough to start out with, is the data lake does not shortcut the process of data governance. It, if anything, increases it. You still have to do the same data governance you would with a relational database. Where people failed was they could think they can put everything in a data lake and it's this magical land of unicorns and wizards and the data will come out fine. Well, no, it won't. You have to think through how you want to design the data lake. And many times customers will put it in layers. And there could be many layers or just a couple layers. Here I put 4 layers. You have your raw, then you clean it and put it in that cleanse data layer. Then maybe you join the data and do mastering it and do other things to get into an application data layer where it's ready to be presented. And then off to the side, you may have a sandbox data layer where somebody, a data scientist, say wants to play with the data in there. But to avoid that data swamp, you have to think through these things. And then within each layer, and thanks to Melissa Coates who came up with this slide, there is different ways in each layer to create folders. And many times you're going to have multiple folders underneath the covers in there. So maybe the top one could be a prod and test and dev, and then underneath that maybe you break it out by subject area or by time or by security. The thing to understand about a data lake is it's file-based security. So if I put or folder-based, so if I have a folder and everything, and I put certain security, everything that gets dumped in there, whoever has access to that folder has access to all those files. So I better make sure those files are security-wise or things that person can see. So maybe I have to separate out folders by security and do it that way to avoid having people see things they shouldn't in there. So you got to really think through all this. And many times you'll have many different layers of folders also because of performance. If I'm running a query, I don't want to have one folder with 1 million files in there. I better have a bunch of different folders with smaller subset of files so the query runs a lot faster on there. So this is the things you got to think through, spend a good amount of time designing it, and figuring it's going to work best for your particular use case. Why do I use Hadoop as a data lake in there? Well, Hadoop's been around for quite a long time. I'm seeing a lot less use for it outside of the data lake. It still has a lot of great products. Many of them are free from the Apache site. You can use those and you can do pretty much anything in Hadoop in there. But it's changed what the main benefit it was. It used to be for handling tons of data. The Googles and Yahoos started out using it, but then companies realized they're not at that size. They don't need it for that type of querying in there. But so Hadoop went from being the solution to everything to let's find a better use case for Hadoop, which became that data lake in there. And there's always a lot of confusion on what exactly is Hadoop. It's usually a few parts, HDFS, MapReduce, some other tools in there. So is it Hadoop if I'm just using HDFS? You can argue it either way. But that's the way I think Hadoop is, at least using the Hadoop distributed file system on there. And Hadoop has really succeeds in that huge volumes of data. But as I mentioned, many companies just don't have that much data that they're running queries. They're going to take hours and days to do. And so they continue to use a relational database and many times still tabular models and cubes, but still use Hadoop in fitting in that data lake space. And if we look at Hadoop solutions and HDI, Hortonworks Data Platform, HDP, is underneath the covers of HDInsights. It's a Microsoft solution, and many people just don't realize it. HDInsights is nothing more than Hortonworks underneath the cover. They grouped all these products together because what reason Hortonworks Cloud Area got founded was it was so difficult for end users to go to the Apache.org site and just start downloading all these products and making them all work together. So Hortonworks and Cloud Area came along and said, we'll group all these products together, we'll put them on one VM that you can use, and we'll guarantee all these products will work together. And they have, over the time, they update this HTTP to have newer versions of the products on there, and then they provide support. And they don't really create much new, that rather they just make it more convenient for you to put all these things together in there. So they tie them all together. There's about 20 of the products in there. And you can think if I go to Microsoft's Azure and I fire up an HDInsight cluster, I'm going to get access to all these different tools. But do I want to use those tools for building out a modern data warehouse solely without a relational database? And this is where I had this slide. It's a little dated now, but I still feel it holds true, is if I try to do everything in a data lake, am I saving money? Well, no, because what happens is as you start coding, it takes longer and longer, and it's more difficult to code things without a relational database in there. So while it may be cheap for using software that's free and maybe more commodity hardware, which I never see anyways, but the idea is that it could be cheaper. But when you start adding in the cost, which shows in building an enterprise data warehouse, to build those queries, the complex queries, and do ETL, it winds up costing a lot more. And I find this to be very true. And that's one reason why companies, when they started out saying we'll do everything Hadoop, quickly abandoned it because of the complexity of building solutions, the lack of skill sets, having all these people, administrators and other people monitoring the solution was a real hassle. And so they quickly incorporated a relational database and a data lake in there. So when we're looking at the modern data warehouse, you also want to think about the future needs. I touched on some of these. I have more data volumes in there. I need real-time performance. I have various new data sources and types. I have data that's born in the cloud. I have a multi-platform solution in there, and I maybe want a hybrid architecture on-prem and in the cloud in there. I'd like to say the answer would be this easy. I'm going to have all my sources. I go in an enterprise data warehouse, and I'm sitting on a keyboard nice and happy. But here's the reality of a modern data warehouse. There's a lot of complexity to it. This is just one option of many products you can cobble together. I left out a lot of products in here, but I see companies will use many of these listed products on here to build it out, because while it adds more complexity, you're able to consume data, again, no matter what the size, the speed, or velocity. You never have to go to an end user and say, no, I can't incorporate the data in here. If you build it out right from the beginning, it can incorporate any of that data in there. And this is what it may look like in there. So I may have all these various tools to ingest the data and land it. And I like to think of 4 areas. I'm ingesting the data is one category of sets of tools, and then storing the data, something like Data Lake Storage Gen 2 is another area, and then transforming it, where I can, in this slide, I can use things like Databricks, and then modeling the data in a product like SQL Data Warehouse in here. I may supplement that with analysis services. However, no matter where the data is and where its stage is, if you have the skill set, you can use a product like Power BI or Excel to grab the data, and whether it be in the data lake store or in SQL Data Warehouse or analysis services. When I talk to the companies about how do they better understand the difference between data lake and data warehouse in a modern data warehouse solution, it comes into, think of the data lake as your staging and prep area, and think of the data warehouse as a serving security and compliance area, especially around security, because it's so difficult to set up data security correctly and easily in a data lake because it's file-based. Where in a data warehouse, when you have things like row-level security, column-level security, it's much easier to set up security. Think of if I have a file and it's millions of rows and and each row contains a department number, and I want to have it so end users can only access certain departments. If they're going to access in a data lake, that means I have to break that file apart, put it in different folders, give access to each of those folders, which can be very complex if users can have different departments they can see. Let's save that for the data warehouse because it's much easier with the tool sets they have in there. And so I'll see a number of companies, they'll say, we're not going to have any end users access the data lake other than data scientists and a few handful of power users. Let's do all security through the data warehouse because we've done it that way for years. It works great. So instead, let's use data lake for the staging and the cleaning and preparation of the data in there. And for the other reasons listed in here. And so your data warehouse becomes that serving layer and is the area where the queries are landing, and the end users become very happy because they can pull data out of there. They understand the relational data model, and they're much easier than the data lake. At Microsoft, we have a lot of solutions, and I listed some of them here. And this is more of a takeaway to know the products that we have. I find at Microsoft the biggest challenge is with customers not knowing the products we have. They'll come in here, even if they've been using Microsoft products for years, and not realize we have what we do in the cloud in there. So it's a lot of education I do. Of course, Microsoft doesn't make it easy because we're always, which is a good thing, always adding new technology, always adding new products on there. And it's up to me as an architect at Microsoft to help customers understand what these new products are and their use cases. I do that through my blog, and I do it through a lot of interactions with customers because customers are busy keeping what they have running in there, and they don't have a lot of time to learn all this new stuff in there. So that's where architects at Microsoft help out. And here's where I categorized. I talked about before the ingest, store, prep, and model, and I tried to put all the categories, all the products that fit in certain categories, understands that some of these products fit more than one category. You look at Azure Data Factory now with its data flow capabilities in there. It can stretch out into multiple areas, even with Power BI too, with its data flow capability in there. That can be an ingest and a store and prep, and even a model now in there. So Power BI in essence can do everything. The whole of the conversation when I have with customers is Power BI can do a lot of these things, but understand Power BI is more a self-serve ETL and reporting tool and not an enterprise tool. And Azure Data Factory becomes an enterprise tool. And there are ways you can go from one to the other, but always understand with customers is if I have an end user going and building a solution in Power BI, is he thinking of this to be used for the whole enterprise in there? Many times that person is not. And while they can help out by doing some of the work in Power BI of cleaning the data, and maybe I make that part of the enterprise solution in there, but think of that more as an individual use tool set and not something that you're going to have as an enterprise solution in here. So then this is what I spend the whole day with customers is going through all these products, all these different options in there. I ask them questions of what they have now. One of the most important is what's your skill set, because I'm not going to recommend something like a Databricks if they are very adverse to Spark and Hadoop and they don't have any of that skill set, but they have a bunch of SSIS programmers and developers in there, then I'm going to guide them in a certain way in there. And there's also many products that Microsoft has in private preview, which unfortunately I can't talk about yet, but you can bet on my blog when they first come out to be announced in public preview, I'll put it on there. But a lot of them will fill some of the gaps that we have in this deck where I feel like there's a couple of areas that we could do better, and we have those coming out soon. If we look at a high level, some of these architectures, this is one I see very common. I take data from a bunch of different sources. I use Azure Data Factory to land it into Data Lake Store Gen 2. I can then run Databricks and use notebooks to clean that data and either write it back out to the Data Lake Store in a clean layer, or because Databricks integrates well with Data Warehouse, I can write it right out to Data Warehouse. Most of the times I recommend putting it in the clean layer and then in the Data Lake. This way other people can access it outside of the Data Warehouse, those data scientists in there. Also, this solution kind of touches on it where I can have poly-based loading data in a data warehouse. I can also be querying this data through Power BI. I can be transferring them in Databricks. So this is the great thing about separating storage from compute, is that storage can be accessed by many different tools all at the same time. I even see customers will land different areas of the data lake and they'll have various Databricks clusters fire up and clean all that data, and each one pointing in different folders, so they're parallelizing the cleaning of that data in there. The water gets muddied when we start looking at things like Data Factory with its data flows in there. That can be used for transforming the data, and so that can be used in replace of Databricks and such. Even understanding that it uses Databricks, something that covers. So think of the data flows as sort of putting a pretty interface over Databricks, so you don't have to write code in there. You can rather just visually design solutions to transform the data. So we landed in a data warehouse. We still may want to use analysis services because of concurrency. The data warehouse is not great at having a dashboard which could have many queries behind the scenes hitting the data warehouse when you're dealing with hundreds or thousands of users, because of some limitations on how much concurrent queries can go on there, and because even of the performance. I can have a product like SQL Data Warehouse which can run queries that just over millions or billions of rows in a couple of seconds, but that may be too slow for a dashboard where I'm slicing and dicing. I need that done in milliseconds. So that's where analysis services still comes into play frequently with customers. Again, money in the water. Analysis services now is sort of built into Power BI, and that's expanding. So we're starting to see customers that are using just Power BI because it has that tabular model underneath the covers in there. That gets into an enterprise versus individual solution outside of the scope of this, but we still have a lot of people use analysis services. We can look at a hub and spoke. We're expanding on the previous slide is things will go into the data warehouse, and then they will export it or copy that data out into data marts and data cubes in here. And so one of the ways customers are using this is our product SQL Data Warehouse. You can pause it. So if I have this solution, because SQL Data Warehouses can be costly, I can use it to process the cubes and process some data and maybe do transformations in it, and then it creates a copy of it, and then it's paused, and users just access the data marts or data cubes, and then they go back to the data warehouse maybe only if there's a query that's not answered with the cube or the data mart. Federated query is, I'm seeing some talk on this now. Think of it as data virtualization or logical data warehouse. Other terms of it is I can run a query, and on data as it sits, I don't have to ETL it in. And this could be very useful, especially if I need to have maybe a one-time report. I'm not so much concerned with speed, or I just want to see if this data has value without having to write any ETL to it. I can start using federated query, and Microsoft has, you can do that with Polybase with some caveats. We're coming out with other products that are going to make this easier, and I think this will be something that'll be used going forward with some trade-offs of performance when you have federated queries. Think of Polybase on here. In 2019, it now adds support for competitive products like Teradata and Oracle, and I can run a query that can pull the data as it sits in all these different sources without having to write ETL in there. This will be really cool for that. I have data in multiple sources. I want to run a query one time and I'm done with it. This will work great. The trade-offs are you're not going to get the speed you need if you put everything in a local data warehouse. You have issues with indexing that may not work well in a solution like this. Where you're going to clean the data, where you're going to master data, you can't really do that in a solution like this. But it does have some great use cases on there, and I'll expand more about this in some blogs as Microsoft comes out with new products for this. When I look at the solution benefits to the cloud, fortunately with customers, I don't have to talk about this too much more, especially with the bigger companies. Many times when they come in to the Microsoft Technology Center, they've already got an etiquette from above. We're getting rid of our data center in 2 years, maybe a year, and help us migrate to the cloud. For those that are still thinking about it, maybe the smaller and medium-sized companies, I talk about the benefits, and at a high level, and I can go over these details forever with a customer because there's so many benefits of the cloud, but at a high level, it's you look at the unlimited elastic scale and you pay as you go. So I don't have to spend a lot of money up front. build out a solution. And I also say it's like failing in the innovation part. It becomes fail fast. If something doesn't work out, I can just shut everything down. I'm not paying anything anymore. You can't do that with on-prem. It gives me quick time to market. I can go to the Azure portal. Within a minute or two, I can have a VM or a SQL database all running in there. Compare that to startup time that it would take on-prem to get something, which would take weeks or months to order it and rack it and stack it and configure it. And then you're dealing with the maintenance of that. Microsoft in our cloud handles everything outside of the VM. If you look at our integration as a service, IaaS products in there, the networking, the disk, the cabling, all that stuff, any problems, we take care of them. Unless you like getting calls 2 a.m. in the morning that something's wrong with the SAN, those issues go away and you can focus on building solutions. You take it a step further with their PaaS solutions, which the concept of VM goes away. You don't have to remote into anything. It's automatically patched for you. So your life becomes a lot easier with having to deal with those maintenance and upgrade headaches in there. And touching on the risk is the availability, reliability, security is way better in the cloud than anything you have on-prem. Those arguments with customers about security have pretty much gone away, but we still have customers that don't quite understand that the level of security we have in the Azure cloud. We can supplement that by explaining to them the security, but also showing them through data center tours and things that the security is way better than anything they have on-prem. The reliability, I talked briefly about 11.9s with data. Everything that's written out to Azure is copied 3 times in there. So that's how they get the 11.9s. You can have it geo-replicated to other regions for disaster recovery. You can go up to 16.9s. And then the availability to SLAs we have on a product, some more 2.9s, 3.9s, 4.9s in there. Much better than anything you would get on-prem. And those guests get asked, well, what's the cost? And we have this total cost of ownership calculator link on here. When people ask about the cost of keeping things on-prem versus in the cloud, you can run through this in there. And there's a lot of indirect costs, because how do you really put a value on time to market? If I can start building a solution in minutes in the cloud as opposed to weeks on-prem, how do I put a dollar figure to that in there? But that ownership will allow you to calculate things that are a little more obvious. If we think of on-premise data, we have some of these constraints on there. The CapEx, all the upfront costs in there. The staff of employees and consultants that we need to keep things running in there. The need for tuning and deployment. I tell companies who have an on-prem data center, you're in the air conditioning business. Why would you want to be that? That's not your core focus, your company there. Let Microsoft handle it all. It's like, would you want to do all your taxes? No, you outsource that. We'll outsource data centers to Microsoft. And I always talk with companies, the talking points when you're dealing with the cloud is a public and private cloud and the difference between the two. And we call ours a public cloud, but I don't like that name because it's not like anybody can access to it because of level of security. But we have other options in there. We have government clouds, and there are different layers of that. We even have a secret cloud now, which I can't say on the air, else they'll come and arrest me. But they have such a high level of security on some of these that we get these high-level standards, stamps of approval for security reasons on there. You also want to think about cloud-board data versus on-prem data, because now we start getting into, and this is the issue with the cloud, is the data that I can have on-prem needs to be moved to the cloud. So how do I move it there efficiently? Because on-prem it could be very easy. 2 servers are sitting next to each other. I just copy it over and it's very quickly. Well, now if I have it go over into the Azure cloud, I'm limited by the bandwidth that I have between my data center and the cloud in there. And that's where we get the products like ExpressRoute, where you give a better pipeline. Maybe you want to update the data more frequently than at night and things like that. So this is part of the conversation I have with customers of how to adjust around that. We'll start talking about the cost of moving data in and out, because there's some things that could add up minor as pennies, but it could add up over time if you're dealing with petabytes of data. We'll also talk about with sensitive data and how you want to best handle that in the cloud. Maybe that's going to depending on your company, a government cloud and such in there, but there are different ways of securing that data in the cloud, way more than you have on-prem in there. And then every company is hybrid. There's no company that just all in one swath moves everything to the cloud. It's always moving things in partial. So we have to look at hybrid solutions, which Microsoft's very good at, because we have a lot of products that, and we started from on-prem and now have a lot of similar in the cloud products in there. I'll briefly touch on SMP versus MPP. This is the idea of SMP is traditional, where I run queries through a server. One query can take down the whole server. All I can do is scale up and buy better hardware. And that MPP separates the data out, and it takes data and it spreads it out among multiple servers, so it's scaling it out. Each time I submit a query in an MPP solution, it breaks the query up into smaller queries. They run locally and then return the results back, mash them together, and give it to the end user. And I can have queries that can take forever on MPP and not affect other queries in there, because each query gets its own CPU and memory on that. So it avoids that issue you can have where I have to use the kill command because somebody's run a malformed query and it's taking everything up in there. So when you look at some of our products like SQL Data Warehouse, that's when MPP comes into place. So that product, and along the lines of Snowflake, those all can be great solutions when you have queries that are just taking too long. You look at an MPP solution. And this is where that comes into play. As we get more data, but also have more complex queries, more sophisticated schemas, we want to refresh more often. This is where we are maybe going outside the bounds of what S&P can do, and we want to get into an MPP solution. So I'll summarize it, and I'll take some questions. It's a data-intensive world. You may hear the data is the new gold and the new oil, and it's very true. It's all about getting better business value out of your data. And the way to do that is to use better tools, have a modern data warehouse approach, but also incorporate more and more types of data. And really the cloud's set up to make you succeed by being able to capture all that extra data in there. And then we get into real time, which I'm seeing more and more of. Maybe that's streaming data in Twitter, maybe that's IoT devices. The modern data warehouse can have solutions, which I didn't really touch on in here because that could be a few other different products, but things like IoT Hub and such, and Azure Stream Analytics, but those can be used in a modern data warehouse. So always think, am I going to have some real-time need in there, and then take that into your design of a modern data warehouse architecture. And it's just a big business opportunity. If you're not doing it, then your competitors are, and so you need to really look into building a modern data warehouse. So with that, I will take some questions.
All right, so we've got a number of questions here. We've only got a few minutes, so we probably don't have time to cover all of them. But what I can do, James, is we can go through as many as we can, and then I can send you the questions, and if you want to blog about them, or if folks want to reach out to you, because I think you did. Perfect. Yeah, your email is on there, so please jot down James' email if there's not time to cover your question. You can reach out to him. So let's get started here. So the first one is, what is the use case using data lake for relational data sources? For example, moving from SQL Server Data Warehouse to data lake, keeping in mind the needs for ACID.
Yeah, so and this is where I talked about the benefits of the data lake, and I'll just go back to that slide, and why I get asked, do I need to put relational database in there? I actually have a blog on that, and the answer is you don't have to put all relational data in there. Maybe it's a small reference table, and nobody's going to ever need it in the data lake in there, but many times if you don't do that, then you have some data scientists coming back and saying, well, I need this data and it's not in the data lake in there. Can you put it in there? And now you have to go back, and sometimes people go the other way and they put it from the data warehouse back into the data lake in kind of reverse order in there. But to hit on a lot of these points in here, this is the benefit you'll get in there. Maybe I need to, is that data clean is the first thing I'll ask. If not, then where are you going to clean it? You don't want to copy it to the data warehouse and then clean it. You're defeating the whole purpose of having a data lake in there. So, and because there's an extra cost of relational data, and that's where I'm cognizant of. If I have data in the SQL database on-prem, I have to export it out into, say, a CSV pipe deployment, and then move it to a data lake, and then move it back from there into a data warehouse, a relational database. Why do I want to go through all that? Well, here's the reasons why, looking through this and there. And the biggest one becomes, I'm a data scientist. I want to use that data in conjunction with other data. I want to see if it's got use, and I need it to be all in the data lake in there to start getting value out of that data. But you don't have to have all of that, and that's why you have to look at case-by-case basis.
All right. And then let's see here. Do you use the data lake to store referential data as well, like staging and landing layer? And if so, is this data structured in the data lake when it is loaded, or do you have to, cut off part of it, reprocess the schema?
Yeah, this gets into data lake layers. You land it as the data is in a raw layer, and then the question comes, how much do I want to clean it and model it and do all these things in there for it to be in that clean layer for then maybe the data scientists to go? Because the major reason is you just don't want to have a data scientist spending their time cleaning the data, and every data scientist is doing their own cleaning in there. So you process some of that data in the data lake by cleaning it in there. You can master it, which involves a whole other set of tools and work in there. So I'm not quite sure if I got that question. Feel free to answer me afterwards in there, and we can go into it a little more detail.
All right. And then you already mentioned this earlier, but somebody had asked if you're planning to share the PowerPoint, and that is yes.
Yeah, and I'll send it to you, Jason, if you distribute it that way, and it's also on my site too.
Cool. And then let's see here. Where'd it go? Let's see. Do you have any slides on PBI data flows, aka CDM folders, acting as a servicing layer between ADL Gen 2 and PBI?
Yeah, I didn't put common data model in here. I do have a blog about it. So again, I'm referencing back to my blog, but the CDM is going to be interesting to see how that plays in a data lake. Here's the way I think of CDM as it is now. It's an area carved out in your data lake with a common data model. And that allows me to pull data in from these sources. Think of it maybe as a customer, and I want to build my own model. So I use a common data model that has customer layout in there, a customer model, and I can pull that data, and I already have that modeling done. So it's jump-starting my building a solution out. But it's still just a folder in the data lake in here, and not all the Microsoft products interface with that yet. And then there's still the idea is I need to copy it from the data lake into a relational database because I'm not going to just use a data lake. So I need to also build that model out in a relational database. So I'm still trying to get my head around this, and Melissa and I have had those conversations too with how does this fit in with everything in there. And so I'm just going to say I still want to think about it and see how we update some of our other tools to work with it. It's got a lot of great possibilities, in particular because we have these things called accelerators, like a healthcare accelerator where they're having the models out. So in the bottom, it's going to be, hey, this is great. I don't have to build my own model. Microsoft's done it for me. It's just better understanding how that model is going to interface with all the other products.
All right, excellent. We do have still about a dozen questions, so I'm just going to send these over to you, James. And of course, anyone whose question didn't get answered, please reach out to James with the email address that he provided there. We always just try to keep these sessions to the 1 hour time frame that we aim for, so keep everyone focused here. And so I'd like to thank everyone for joining us today. Our next presentation is this week on Thursday. And thanks, James, for the presentation today. Obviously, this was this is the most questions we have in a while, so obviously this is an area where people are very interested. So thank you again for presenting.
Yeah, glad to help, and send those follow-up questions. I love to answer them.
Will do. All right, thanks, and goodbye, everyone.
All right, thank you.